The transform holds the position and any kind of translation that we need to do for the actual game objects or whatever it might be. So this we can hold, move around, and change things within it. So this is position of the enemy, anything like that. That's what it holds. Okay, so then we need a float. We want the width of our enemy. So this allows us then, if we know the width, that if it's moving off the end of our sort of platform, we know that. So that's kind of self describes itself. So we want a vector 2 for our velocity. So we want a vector 2 because we're moving it in the x and y. So this is the x and y of the enemy. There. I want to check whether it's grounded, same as we did with our main player. So check whether the enemy is grounded. Like so. Now this vector 2 here, this is the distance that we have from the bottom of our player, of our of our enemy. So distance from the, and it's probably easy to view this. It's this point here to the bottom of our line cast. Now you can define this. Now something to consider, that if we have if we have a line that is too deep, what might happen is that you might include, as it runs off the edge, pieces like this, other parts of the ground. So you want it to be reasonably shallow, but it also needs to be able to recognise other parts. So you don't want it to be too shallow. So we need to set a distance there. So this is the distance that we have to be negative. So it's moving downwards in a down direction. So distance from the bottom of the enemy. So there are we want to just just want to make those all in line. Open things up a little bit. Make things more readable. All your comments should always be readable, nicely sorted like so. Okay, that's good. Now, what we need to do then is initialize some of these things. So we've got an enemy transform. We can use this. So this means the actual whatever this game object, this script is actually relating to this game object. So we can use this. So this transform. So we have this. So we're initializing our starts. And then our enemy body, we're using the get component of our rigid body. So we've got a rigid body 2D. So we've applied a rigid body so we can get that rigid body. This part is a little bit slightly more complex. What we can use is actually the sprite renderer. So the sprite that is used within Unity, we can grab that sprite renderer. Now it has a number of, so the bounds of the sprite itself. So the bounds that are around the sprite here, we've got the actual collider, but the bounds of the sprite itself, we can grab those. And to what extent? So it extends, so the actual ends of it, and we want that. We want it in the x direction, so not in the y, but in our x direction. So that's what we're getting the width. So how far out it goes. So that gives us the width. So that's what that is. That's how that's so now fixed. What do we want it to do? So this is our line cast. This is where we want to actually produce a line cast. As I was saying in this kind of diagram, we can use this line casting, and this allows us to actually produce a collision based upon this line here. So anything within this line from this point, so kind of from this point here, this point here, anything within this line would be like a collision. So we're using a vector tool, and we're going to call this line cast position because we want it's a position. So remember, our vector 2 is just 2 points. So 2. So we're getting our position for our enemy transform. So we have that position, and then we're going to minus our enemy transform dot right times the width. Now, enemy transform dot right is the right hand movement of our position. So we have the right hand side of it, and then we're going to multiply by the width, this. It gives us that position. We have a boolean, so we're checking that. So what we want to do is use the physics 2D line cast. Now the physics 2D line cast is that kind of it talks about ray casting. You can use ray casting as well, but line cast is a more accurate way of doing it in this sort of position. We can use ray casting, and you can talk to your lab tutor about ray casting or myself. But line casting is more accurate. Ray casting just goes from one point outwards. So a ray cast would be, say we had a position, it would just be outwards from that, and then it collides with something. So if this was a block or something, it just collides with that. Whereas with a line cast, we actually define the point it goes from. So therefrom actually to, like that. Whereas a ray cast, we're just going, actually, where is it from? Here. Not where it's actually going to. So whatever it collides with, whereas anything that's in between a line cast, we're defining. So this is our line cast. So we have our line cast position. So that's our initial position, which is here. So we have our initial position, and then we're saying from there to the distance. So this is from our initial position plus a distance. So this is our distance downwards, and then we're saying if it interacts with any ground items. Now remember we said that these are all our ground items, because they're in ground, on the layer ground. Does it interact with any ground between that point, from one point to another? So does that line cast interact with any ground? Now we can check this. We're going to use a debug to actually check where that line is. And this is really useful using debug.drawLine. And you'll see actually when I run this for my one up here, I've got a line at the end, and that's showing from the position. And you can see it's at the end of our character here. That position, where it is from the beginning to the bottom, downwards, and where it's starting, when it's finishing, and what it's interacting with. And that's the debug line, because obviously we're not seeing that in the game itself. You can see no line there, but you can check that out. You can see there's no line there. So that's really useful. That helps you to see what your line is. So this next part is activated when enemy is not grounded. So once you found that the enemy is not grounded, what we can do is actually rotate our enemy through 180 degrees. So what we can do is actually get a current rotation, and we can place our angles. So we've got, or I should say, the position of our enemy, X, Y, Z position of our enemy using the Euler angles. So we can do that here. So we gain those, place that into our current rotation, and then rotate enemy by 180 degrees. Then we can place that back into our Euler angles. So we gain it and then hold it and then place it back into our Euler angles, because the Euler angles actually hold the X, Y, Z position. So if it's not grounded, we rotate it, place it back in, and off we go again. The last part of this is actually just moving forward. So in a similar sort of way, excuse me, we have our enemy velocity. So we gain that from the body, so our enemy body, which is our 2D, which your body remember. Now we get the the transform right of it. So you used to have left as well included, but that's been removed in later versions of Unity. So we need to negate that. So we have a negative of that, times it by the enemy speed, and then we place that back into our velocity. Excuse me. Okay, so that's basically where we are. So we can use this script now in our Unity. So with our highlight our enemy slime, we grab our enemy script. However we want to add it, we can either add it like this, just drop it on, or other ways, and we should be able to see that we have our script. We have a speed, which is a public variable. I'll keep that at 1 at the moment. But what we do need to do is just highlight our ground items and actually give it ground, which we've created previously for our other objects. So if I now run this, what we should see is we have our line here, which is our line cast, and as it moves past our end of our platform, actually rotates it. And I can change the speed of this, enemy speed here. If I change that to 0.5, you see it slows down, and we can actually see that it moves past that end line and rotates round. And we could speed that back up again if we wanted to make it super quick. So there you go, you've got your enemy moving. Okay.